Hey, you guys, this is Mrs. Shrout. I am an eighth grade science teacher here at the middle school. I'm one of two of the super awesome eighth grade science teachers and one of the 6 science teachers in our building. And our goal today is just for you to guys get those kind of basics. So we're going to watch the video you just watched again. But this time there's some questions you're going to have to answer during it. So we want to make sure you get some information out of it. First question is going to be, what is the difference between a solar and lunar eclipse? Let me say that again, because I know some of you still weren't listening yet. What are some differences between a solar and a lunar eclipse? Now, notice I said the word some. That means more than one. That means probably 2. So, what are some differences between a solar and lunar eclipse? So you're going to watch this first segment, and then I'm going to give you instructions. So enjoy.
A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse, and it happens roughly every year and a half somewhere on Earth. A partial solar eclipse is more common, happening at least twice a year. A lunar eclipse, on the other hand, is where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. The easy way to remember the difference is to remember what gets darker. With the solar eclipse, the sun gets darker, and during a lunar eclipse, the moon does. A solar...
Okay, teachers. So in just a minute, I'm going to have you stop the video. Okay, you guys, students. So some differences between solar and lunar eclipses. Turn to somebody next to you and talk about what you learned from the video about some differences between solar and lunar eclipses. Teacher, stop the video. All right, you guys, so you just talked with your partner about some differences between solar and lunar eclipses. Let me make sure you said some facts. Hopefully you talked about that in a solar eclipse, the moon is in between the Earth and the sun. But in a lunar eclipse, the Earth is in between. So again, in a solar eclipse, the moon is in between. In a lunar eclipse, the Earth is in between. Next, you talked about that in a solar eclipse only happens about every 1.5 years, and a lunar eclipse is much more common. You also talked about that in a solar eclipse, the moon blocks the light, and in a lunar eclipse, the Earth blocks the light. But you said that in a solar eclipse, the sun gets dark, and in a lunar eclipse, the moon gets dark. I bet you also might have talked about that in a lunar eclipse, the moon gets red. I hope you talked about those. So the next segment, here is what you need to figure out. I want to know what all this is excitement about. We always say that Missouri is so boring. There's nothing to do here. Nothing fun ever happens in Fulton, Missouri. Well, something really fun and cool and exciting is going to happen. It's called the eclipse. So what's the big deal? What is all the excitement about the eclipse? Why are people coming from all over the world to here, to Fulton, to see the eclipse? So that's the next segment you need to come up with that answer from. What is all the excitement about? What's the big deal about this solar eclipse?
Solar eclipse is a rare event that not many get to see because the moon's shadow is relatively small. This limits the locations on Earth that get to see it. You have to be on the sunny side of the planet, and you have to be in the path of the moon's shadow. So, if you find your area in the path of totality 1 year, you've hit the jackpot, because on average, that same spot on Earth will only get to see a solar eclipse every 375 years.
All right, you guys. So again, turn to your partner and talk about what's the big deal. Why is everybody so excited about this eclipse on Monday? Teacher, go ahead and pause it. All right, you guys. So you just talked about what's all this excitement about this eclipse. Hopefully you talked about, first of all, amazing that it happens every 375 years. in one location. So I don't know about you, but I don't want to see myself in 375 years. So I'm happy to see it right now. Also, it talked about that, you have to be on the sun side of the earth when it's going to happen. Not going to be helpful if it's night time. I talked about it's pretty rare, that the shadow of the moon is really small. So it's a small path area. So this is 375 years. Pretty darn big deal. All right. So watch this next segment on the shadow of the moon.
During a solar eclipse, the moon casts a shadow with two parts, the umbra and penumbra. The moon's umbra is part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending some 400,000 kilometers behind the moon. It's when the small end of this cone hits the Earth that we experience a total solar eclipse. Most eclipse maps depicting the path will show you a circle representing the shadow of the moon, but in actuality, the true shape of the umbra is more like an irregular polygon with slightly curved edges.
Okay, you see this confused face? They said it's an irregular, and look at the picture. It's an irregular an irregular polygon. So why do you guys think it's an irregular polygon? Let's put our science hypothesizing caps on, and I want you again to turn to somebody and hypothesize, why do you think it's not a nice oval? Why is it that polygon shape? Okay. All right. So now you've talked with the people around you about why it's the polygon shape. And now you're going to share as a class. Teacher, go ahead and stop the video. Share it. All right. So you guys have done your hypothesizing. So now it's time to see what's the thing going on about that shape.
This is because the moon isn't a perfect circle. It has mountains and valleys on the surface, which all affect the passing sunlight and subsequent shape of its shadow. And scientists now have a greater understanding of the shape of the moon's surface, thanks to NASA's Lunar Reconnaissance Orbiter. The unprecedented level of detail on the topographic maps, photos, and other data sets has allowed us to more precisely pinpoint the regions on Earth falling within the path of totality of a solar eclipse. So, if you get the chance to witness a solar eclipse, always remember that our little moon plays a role that's quite large.
Okay, you guys. So you just learned hopefully a whole bunch about the solar eclipse. First of all, learn the difference between a solar and lunar eclipse. You learn what all this cool excitement is about. You learned why it's that weird shape. It's not the normal oval shape. So one last thing I want you to talk to a partner about is, how have these satellites in space helped us learn this information? What have we learned from the satellites that has helped us here on Earth learn more about lunar eclipses? Go ahead and share with your partner, and then share as a class. And I will see you guys later.